All right. How is everybody doing? Yeah, so what the topic of my presentation is why Kubernetes is not enough. I think it was a clickbait topic to get you guys all here. We are not going to talk about all the bad things about Kubernetes or anything like that. Kubernetes is a great platform. We love it at Farfetch. The idea behind the talk is to get all of us just to start thinking about what does it take to run large-scale infrastructure in a company like Farfetch, and why certain trends like Kubernetes are not enough to run this large-scale infrastructure and stack. There is going to be some storytelling and just sharing of experiences of what I have seen in my journey on decisions that we have to make, areas that we have to focus, and stuff that we have to build in order to put all of this together. So yeah, I think that's what the talk is all about. A little bit about myself. So I've been in the industry for 18 years now. Majority of my time was spent in Silicon Valley working for product companies, mostly enterprise startups and bigger companies. And for the last 6 years, I've been working in web scale companies, trying to help them manage and scale their infrastructure and security. And it's a very different experience. The DNA of the two kinds of companies, enterprise versus web, is slightly different. And the kind of challenges to run these massive large-scale enterprises, which are moving at an incredible pace and innovating on a daily basis, is quite different and quite challenging. One of the common things that I've seen in my journey working with web-scale companies is the sheer complexity of the ecosystem itself. I mean, we are talking about microservices, very common thing nowadays. Everybody understands what microservices are, why they are, and what benefit. But in reality, when you put it in live and when you're managing it on a daily basis, the kind of stuff that gets thrown at you in order to manage is just incredible. So simplifying that stack, understanding what you have becomes a very key component of doing it. It's not just the part of building. And that's what my roles have been, just trying to arrange the various pieces of this puzzle in a way that is understandable, manageable, and scalable at a global scale. An introduction about the company. I don't know how many of you know about Farfetch, but Farfetch is one of the largest platform for luxury, technology platform for luxury. We exist for the love of fashion, as you could read here. And our mission is to be a global technology platform for a luxury fashion, connecting creators, curators, and consumers. Now, we might ask, I don't know how many of the audience here is fashion-oriented. I'm clearly not. But it takes a massive amount of technology to build a fashion platform. And that's what we are here to sort of hear today, and I'm here to share today. The journey of the company started about 11 years ago. Our founder and CEO, Jose Neves, he decided to merge the two passions he has, which is fashion and technology, together to form Farfetch. It started off as a marketplace, which basically connected boutiques who were holding a lot of fashion inventory and were not really connected to the digital ecosystem and didn't have the resources to actually do that themselves. And it collected them and gave them a platform, essentially, to connect to the global audience. And this platform evolved into not only serving these boutiques, but also brands, and then, of course, cater to our consumers worldwide. Farfetch is no longer just the Farfetch.com or Farfetch marketplace. It's a combination of a bunch of our group companies. So we have Browns, which is our own boutique in UK. Sure that some of you may have heard of it. So it's a store that we have inside London, which enables us to try a lot of our technology first in our own boutique and then scale it out to thousands of other boutiques that we work with. We also have Store of the Future, which is our connected mirror and augmented reality. It's essentially an IoT group, and it builds technology for the store so that we can merge online and offline together to create a unified experience for our customers. We have Farfetch Platform Solutions that works with several brands and large boutiques like Harrods to power their digital footprint through Farfetch Platform. We have dozens of brands that we entirely run their digital footprint. We have Curiosity China, which is our VIP customer company that we acquired, and it works hand in hand with our team in China, which is already a pretty large organization. We'll talk about some of the complexities of doing business in China next. Very recently, we acquired Stadium Goods in the United States, which is a sneakers shop, and they have very special skills in finding these amazing sneakers, and we are integrating them on Farfetch platform. And latest, NGG is a group company that we have that essentially incubates fashion brands and brings them to market, brands like Off-White, and their combination with Farfetch technology platform can create an end-to-end experience for a brand to go to market. So this sort of gives you an idea that Farfetch is quite an elaborate ecosystem. These are some of the brands that we work with. This is nowhere close to the exhaustive list, but some of the biggest luxury brands in the world are our partners. They work with us both in terms of either running their digital footprint or working with us in terms of putting their products online on our marketplace. To give you a sense of the size, we work with over 1,000 brands and boutiques and departmental stores. We have close to 2 million active customers that transact with us. These customers are located in 190 countries. Our average order value is $580, and we have supplies coming in from over 50 countries. Farfetch went IPO in 2018 in New York Stock Exchange. And if you notice the 3 flags out there, of course, United States, that's our big market, and also where we went IPO. UK, that's where our headquarters are, and Portugal, where some of the biggest teams, such as technology teams and operations teams, are located. As I mentioned, we have customers in 190 countries, which basically means that we have to ship our product to all of these countries globally. That's no mean feat. Each of the country that we ship has its own unique challenge in terms of the custom clearance, the payment systems, the supply chain complexity, returns, and managing all of that with the power of the platform is the value that Farfetch provides. When a new brand comes online or a new boutique comes online, they get access to customers in 190 countries at a click of a button. Farfetch takes care of everything, every step of the way on how to make that product available to them. For an end customer, it's a seamless experience, just like any other website that they go to buy. But behind the scene is what Farfetch platform is doing and killing all the complexity and connecting with all the different pieces along the way to make that experience seamless. And this also has implications from the legal point of view. There are countries like, especially in China, where there are extremely different legal compliance if you want to do business. One of the biggest compliance was about how do we host our stack in China, and we'll talk about that, which made us make massive changes to our platform itself. How do we work? We work globally as well. So Farfetch is located in 13 different countries. Not 13 countries, has 13 different offices. We have offices in US, in UK, in Portugal, also in Dubai, New Delhi, Shanghai. We have a very large team over there. And this complex ecosystem is actually delivered by these really talented people who are located across the world and helping us build this platform. Now, switching gears to technology. So as I mentioned, in order to serve these different countries, we had to comply with the local laws. And one of the laws was about that we had to host our stack internally in those countries. And China was the first example where we had to do it at a massive scale. So right now we are running our platform in 3 data centers, 2 in Europe and 1 in China. The platform is completely redundant and active, meaning that we are running the same copy of our stack in 3 locations in a completely distributed way. Each of the location is self-sufficient to host the entire traffic. And this is the way we did it is by expanding our stack in a way that it can share data, it can replicate data across these 3 different geographies. I don't know if you're familiar with one of the challenges of doing business in China is the Great Firewall, which basically looks at traffic that goes in and out, and they also have, like I said, legal compliances. So we had to change our stack not only in terms of how we will scale out, but also in terms of how data flows in and out. GDPR is another compliance which is on the European side that prevents data from flowing to different geographies. So all of these complexities came in on our lap when we started to think on how to do business in China. And we do that with the help of 1,000+ developers. There are 400 or so microservices that are forming this platform as the one that I talk about. We do a massive amount of builds per month, over 25,000 builds, and over 1,200 deploys happens every week in production. So as you can imagine that this is a complex machinery that keeps churning new features, new fixes throughout globally. So let's take a look at what we build. So our platform it consists of several layers, as you can imagine. One of the layers is of the services that we offer. This could be services like photography or production, where our teams are taking pictures and creating catalogs of the items on our website. This could be inventory management, product catalog, marketing, payments. These are the different services that we offer, and we make that available to anybody who comes on our platform, even things like customer service and fulfillment. At the bottom, we have all this tooling which basically integrates with different partners. It could be boutiques, it could be brands, and we integrate with them to bring their inventory on our site and provide them with the hooks to basically integrate with our platform. Then we have Farfetch applications. These applications could be our website like farfetch.com, our apps, iOS and Android apps. In China, we have several other apps like WeChat stores, which basically is the front end for our platform. And when a partner comes online, they get access to these applications in one click. I already talked about Farfetch Platform Services, which is essentially in the business of creating digital footprints for brands, Store of the Future, different departmental stores. And all of this is Circle. It's basically creates massive amount of data ecosystem and creates a data ecosystem for our platform. So we get signals from all of these different channels, as I just mentioned, from all of these different services I just mentioned, and gives us massive insight into what our customers are doing, what are different brands doing, what trends are happening at a global level, and gives us this unique position where we understand the global data footprint of the luxury space. This, at a very high level, is the idea of Farfetch platform. Farfetch was born in the cloud. What does that mean? We basically are a young company, and we started off by building our applications which are cloud native. So by definition, cloud native applications follows the principles that we are following a microservices architecture. Each service is essentially trying to build a unique business capability. It's independent, got its own stack of database queues, and essentially it offers its service to the others using an API. This allows our services to grow in the cloud and scale out easily. Essentially, we can make use of all the cloud features like auto scaling and elasticity relatively easily. This also helped us when we went from a single data center to 3 data center stack, as I was talking about, because a lot of our services were able to expand very quickly. We did have a lot of services that we had to break down from slightly larger monolith into microservices, and that was the journey that we were on for the last few years. Now, this journey has taught us a lot of things, and we sometimes feel that when we are in a microservices environment, when we are doing containers for our applications, we can very easily move from an environment, an older environment, to a newer environment, or you can think of a VM-based environment to a container-based environment. I don't know what are your experiences, but I clearly have seen that this is a journey. This is a migration path that takes a long time. Even if we feel that we are born in the cloud, even if we are a new age company, it takes a massive amount of time for us to convert all our applications from, let's say, running on a VM to running on containers in Kubernetes. And that's the complexity that we started seeing when we started growing. This is a snapshot of our live infrastructure. These are 3 data centers, as I mentioned, and getting connections from thousands of our customers online at a time. This is a high-level picture of our stack. So it's an extremely simplified view, but hopefully will help us with our conversation going forward. So we use Akamai as the CDN, and there are several services within Akamai that we are making use of. So we use the global traffic manager for Akamai to distribute our traffic to different geos, and it essentially collects signals, whether it's about latency of the link to different data centers, or the kind of traffic, the kind of customer, which region he or she is coming from. There are several data points that it uses to make a decision: where should the connection go, which data center should it hit. We are also using Akamai Image Manager to offload our images onto the CDN so that we don't have to serve them directly unless required. We use Newstar for our DDoS protection, and anytime we see a DDoS attack, we can route our traffic to Newstar to scrub that so that our data centers don't get overloaded with that kind of fake traffic. We have 3 data centers. I've mentioned it several times now. We host our applications, which is either a web stack or an API layer. Our API layer are front-ended with Kong, which is our API gateway. And we use HA proxies on the top for north-south traffic to our website. Underneath, we have a combination of servers, and we're talking about thousands of servers now, which are hosting different applications. And these are not all running containers or Kubernetes. We have a combination of servers which are doing either applications on plain VMs, and then clusters of Kubernetes running containerized applications. Now, this ecosystem coexists. They talk to each other. It's not that only a certain part of our platform runs there, and very cleanly the other part runs here. Now, we are talking about a mesh which connects applications from VMs and containers talking to each other on a regular basis. And this is this complexity. This is the beginning of the complexity of our migration path as we migrate away from VM-based applications to container-based application. And this is going to take time. Underneath, we have several types of databases. This is nowhere close to the exhaustive list of databases that we use, but the most prominent ones, we started off with a .NET application stack. Therefore, we use a lot of SQL Server. But over time, we've adopted a lot of open source technology. So Mongo, Cassandra, Redis, and Elastic have become very common technologies for us to host different kinds of use cases in our business. Cassandra is very special because that's the geo-distributed database that we are using, which is replicating data across the 3 geos. At the bottom, we have Kafka as a message bus for all. As we re-platformed our stack, we become completely event-driven, and we are talking about billions of events being thrown at Kafka on a daily basis. This gets collected across different data centers and gets centrally read from our data stack, which is not even represented here, to create the big data platform which serves the data layer. So hopefully this sort of gives you a high-level idea of the kind of technologies that we are using. Now, this all started not with that picture. I mean, we were back in 2010, a very simple stack when the company started, using simple technologies like .NET, SQL Server, running fewer applications on Windows. I'm sure every startup can relate to that, and maybe the stack is different, but it all starts with a very, very simple technology. Over time, you start adding more tooling, better CI/CD tooling, whether it's ProGet, whether it's Jenkins, start building out apps. Then the big data challenge starts happening, that you start feeling that your relational databases are not enough to create that kind of ecosystem for your big data problems, and you start putting in Hadoop. And we went through a very similar journey, and this is just a sample representation of what it looks like for a company like us, right? We are on to 2020 now. We are putting Kubernetes in production with Istio and experimenting with MLOps, et cetera. But at the end of the day, what we want to get to is not fill up this slide with a bunch of logos, which sort of shows that how complex our stack is, which it is, but to actually drive the conversation that we need to have these technologies mature so that we can enjoy the plateau of productivity. I'm sure you guys are familiar with this graph of trends on how different technologies go through that. I think the sweet spot for us is that when all of these technologies come together and starts creating value for us, because we want to use technology for helping us grow as business, helping us make our stack more robust and more scalable, and not remain in that trough of unhappiness and constant struggle with the newer technology. And that's what our goal is to put all of these technologies together in a way that is cohesive, that works together, and we are actually able to use them rather than constantly struggle with them. So, a few years ago, we started focusing on some of the basic decisions for our stack. We wanted to move away from running Windows as an operating system, even though we've built massive applications in .NET. And right now, we are using Linux as 100% of our infrastructure OS. That means every system that we run is running Linux right now. What does that mean for the Windows applications? For that, we are adopting a technology which is .NET Core, essentially, that now enables Windows applications to be packaged into containers and can be executed on Linux hosts. and we are massively converting our applications from .NET Standard to .NET Core. We are also working very closely with Microsoft to package some of our very large applications, which are natively running .NET Standard, to run in containers on Windows. So this is a technology that is not even GA, and Microsoft, there is an R&D team over there who is working very closely with our engineers to make this application portable on Linux. But at the end of the day, we want a very homogeneous environment where everything is running a single version of operating system, which is Linux, across all the data centers, and applications are something that we throw on it, whether it's .NET, whether it's Java, whether it's Python, or whatnot. I think I missed a point in the previous slide that even though .NET is one of our focus technology in terms of migration, that is not the only technology that we use today to develop applications. We right now have engineers who develop in Java, who develop in Python, and few other languages. We have limited them to a certain number just so that we don't create that ecosystem where it becomes a wild, wild west and we have to go on support everything. But the stack is flexible enough that it can support most of the more common development languages. And the last part is Kubernetes. Now that we are converting ourselves into this dynamic, container-oriented stack, we want to run all of that in Kubernetes. So why is Kubernetes not enough, right? So we'll get to that point very soon. So I mean, there are trends that happens in our space every year, and I'm sure all of you are familiar with it. If you look at the top trend for 2019, I bet Kubernetes will be somewhere on the top. If you look a few years before that, there was DevOps, there was microservices environment. Even before that, there used to be NoSQL. There were several trends that basically made our ecosystem what it is today. And all of those trends and all of these technologies are extremely powerful and extremely good. I'm not debating that. But what is important is for us as leaders, whether it's technical or business, is to understand the cost of these trends. And each of these trends goes through their own maturity cycle, and we have to understand what makes sense for us at what point in time. Because if you don't, then we've seen this problem. If you're running a spaghetti organization, if you do not understand what is happening under the hood of your own ecosystem, then no matter what technology you put, I mean, Kubernetes is representative here, but a spaghetti application stack with Kubernetes is still a spaghetti organization. In fact, it becomes harder and harder as you put newer, trendy tools into your ecosystem. I'll give you an example. One of the things that we started off by asking when we were doing this change of stack, and even before that when we were trying to migrate, was simple questions like, okay, so how many microservices are we running? A simple question like that would draw different answers from different people. It was not only just the fact that we were giving different answers, it was that it's actually more scary to have half information than to have no information. Because you could actually believe in one of that information, make plans, do something like a migration, flip on a switch, and go live, and things won't work. It is much better to say, I don't know in the beginning, because then that forces you to go on that journey to understand and fix some things. Now, that's not cool work. That's dirty work. That's the work that we all tend to avoid. Understand the nitty-gritties, and this stacks up over the years. We are talking about a decade of changes that have happened. Another example of NSGs. We go to our systems, we look at, okay, how many NSGs do we have configured, and it would look scary. Now, you have to now make that change, go to a brand new environment like Kubernetes with that information that you have had. Now, you don't know what NSG somebody opened at some point in time, which is making two applications talk to each other. So when you flip the switch or you go on to do testing, these complexities show up there. So the idea is we have to clean up our house first before we jump onto the bandwagon of a newer technology. Now, I put this slide just to make sure that we understand there is massive amount of benefits for running Kubernetes. Basically, it's a system that allows us to get auto-scaling and auto-healing relatively cheap and relatively easier. Now, of course, I mean, nobody wants to be woken up at 4 a.m. in the morning. If your application is failing, Kubernetes will be able to detect it, put that patch again. Life is good. That's great. But have you imagined if that application is a 40 MB container? Will Kubernetes be able to fix that for you? Will Kubernetes actually make it worse than what it is before? Now, these are the decisions, and these are the sort of use cases that you have to be very careful about. It does load balancing very beautifully. I mean, there are load balancers like Envoy and Istio, and they are giving you this they're giving us the ability to do this service mesh. Containers talk to containers through these beautiful load balancers that probably will be able to scale as well. But what about your car data environments? Should everybody be able to talk to, any service be able to talk to your car data environments, which are basically under PCI scope? There are limited access of services in that environment. Now, if you do not understand how these load balancers are programmed, you've just created a service mess, not a service mesh. And that's what you're trying to protect. You're essentially trying to configure your system to something that you know how it works. It should be configured to a point that you should be able to destroy your system. You should have the confidence, destroy my live system, and recreate it. And it should come up with exactly how you left it before you destroy it. Any manual thing that you've done, any changes that you've done is gone. And you should be able to do it anytime. Now, that's the goal that you want to get to. But it's easier said than done. In a complex environment, it is extremely, extremely difficult. Now, the last thing about rollouts and rollbacks. I mean, we all understand the massive benefit of doing deployments in Kubernetes. It's quick. It does a lot of things for you, canary, blue-greens, rollbacks. It is able to assist us with all these features that we don't have to now worry about because it enables us to do it. But the question is, what happens when you roll back? How many of you have done schema changes in your environment where rollbacks will not work? There you go. So it's a great thing to have rollbacks, but then what are you rolling back? Unless you don't understand that, you will actually create this magic ecosystem that is doing a lot of things for you, but you are completely out of control of this ecosystem. And that's what when I say Kubernetes is not enough, that's what I mean. So what are some of the prerequisites of Kubernetes that we have identified? Get your CI/CD right. And it's one of those things that it's completely mind-boggling. And when I go to conferences like these, it's one of the most talked about subject, CI/CD. And we faced it too. It's a complex problem for a not so complex looking thing. What are we trying to do in CI/CD? We are basically building in our code. We are making them run through various steps, whether it's testing or it's verification, and putting it out there in an environment to be deployed. It doesn't seem that complex. Plus, there are some really, really good tools out there which are doing it for us. So why is it so complex? The complexity is in the integration. The complexity is not in the pipeline itself. It's how you define these pipelines, how you integrate it with different tools, and how do you manage failure. It's very easy to manage success. It's very hard to manage failure. And that's what, get your CI/CD right. One of the massive challenges that we've seen is our testing environments. Now that you have 400 microservices talking to each other, you have essentially created an environment that is no longer going to be easily fit into a single box or something like that that can be tested. So investment on your testing strategies, whether it's mock testing, contract testing, unit testing, is essential to your game now. They are no longer an optional requirements. Second investment is on observability. This is another area of study that is becoming very, very popular. and rightfully so in cloud environments, you need both monitoring and traceability. No longer is monitoring enough. I mean, you need something not only to tell you what is happening right now, what happened in the past, but it's also something that's giving you deep insights into how your services are talking to each other, which basically is tracing. You need to know not only how your service is performing, but how your service is interacting with the rest of the ecosystem. And lastly, about security and cost. These are some of those things that we take for granted, but they are absolutely not. They are the ones that sort of comes and bites us in the behind. Security is everywhere. It's in every deployment, it's in every configuration, and it has to be a first-class citizen when we are doing these massive deployments. Otherwise, what's going to happen is going to eat up so much of our time in just maintenance and compliance and whatnot that it will become very, very hard for us to do. So prerequisites of doing containers. Cost. How many of you are concerned about your infrastructure cost? That sort of gives me an idea of the scale at which we are running. A lot of hands. And that's exactly where we are. Cloud is not cheap. If that's what the industry is telling us, that's wrong. Cloud is not cheap. It is cheap from the point of view that it gives us the ability to use it when we are small without having to invest that kind of time to build that kind of data centers. You know, back when I started developing, we all used to have a little data center in our offices. A lot of the Silicon Valley offices were actually built that way, that the floor should be strong enough to have a data center in each of the offices. Now, we don't need to do any of that, right? We have a startup that can start immediately focusing on the business and rather than having to worry about the infrastructure. But hopefully that startup will grow. Hopefully that startup will require multiple applications, multiple data centers, multiple databases, and things will stop being cheap. So having a pulse on what you're spending your money on is important from the get-go. If you don't have that visibility and you have scaled up, now you're going to be fighting the reverse battle. You'll be trying to fix everything, trying to identify whether it's tagging, whether it's some other visibility, but things are going to get harder and harder and harder. So tackle that problem from the beginning. Your Kubernetes cluster should be able to spit out that information like this. Show me how much is my catalog costing. And it's not just the containers. It's the containers and the load balancers, and it's the databases, and it's the Kafka messages that you're spewing, it's the logs that you're producing. All of that in combination is your cost. There is no tool out there that can give it to you for free. You have to invest time and energy in doing it. But you can't fix something that you can't see. And that's the problem that we started running into. Now, all of these things are great, but I go back to the question, how many services are we running? If the answer is not consistent, if the answer is not true, you can't do any of that I was talking about. So we invested in building something what we call as blueprints. Blueprints are essentially metadata information for all of our services. It's the single point of truth. There is no other truth in the company than the blueprint about a service. There is no wiki, there is no email, there is no document, there is nothing which is the point of truth except the blueprint. It's source controlled, it's maintained by our developers, and that's the origin of every automation in the company. Everything starts from blueprints. Like I said, it's the interface for infrastructure and all other stakeholders, security, engineering, anybody in the company. And it is a hook for the infrastructure as code. All our automation gets fired through the blueprints. Now, what is a blueprint? So let's look inside it section by section. So in the beginning, how are we doing on time? 5 minutes? Oh, OK, so I have to go quickly. So this is an example of, at a very high level, what kind of information we are capturing. It's essentially, like I said, everything about a service, what platform it belongs to, what part of our platform. It's marketing platform, it's the digital boundary, which is an internal nomenclature, and the name of this service is affiliate. That's what it means. And what does it do? It sort of service that manages affiliates. Who are the maintainers? Who are the developers on this? These maintainers list will come handy for us when that developer is going to ask for live access. Because a live access won't be given through a Jira ticket or an email. It'll be given when somebody adds their name to this list, gets an approver, which is like a merge request, and then automatically get their SSH key or whatnot added. So you see, we are tying the security loop through that. What kind of project type it is, meaning is it a .NET, is it Java, is it Python, which basically gives inputs to our CI/CD pipelines on how to build this particular service. It talks about service dependencies. It talks about, oh, I need to access Kafka. That means I need to have a port open to Kafka. And I need a certain topic with certain name, which I add here will automatically go and create that topic for you. You do not have to ask somebody to create that topic. Plus, if you're misusing your topic, you will be caught here because you will be the person responsible from here to know what topic is misbehaving in the system. Who's the producer? Who's the consumer of this topic? What are your database dependencies? We all run microservices, but God honest, we can say that our microservice doesn't peek into somebody else's database? Can we say that? Can we put a hand on our heart and say that? A lot of times, even though services are micro, they like to look into somebody else's database because they don't provide that API yet. How do you make that happen if we do not open a port? This is where we define the database dependency. The ports of only your dependent database is open. You try to sneak into somebody else's database, it won't even allow you. Somebody does a manual configuration, overnight job will come and remove that for you. So tomorrow your application will fail. Your provisioning and deployment, everything that we talked about at Kubernetes, this is equivalent to Helm charts in Kubernetes. Essentially, instead of sort of piggybacking on a single technology, which is Kubernetes, we have created it of our own so that we can grow it independently of that technology. Observability, what are your health URLs? If you're writing a microservice and not providing a health URL, you're not a microservice because guess what? Kubernetes also needs to know when a service is up or down. How do you provide that information? We mandate it over here. We mandate which email will your alert go to, what Slack channel will your alert go to, what is your PagerDuty configuration. All of that is mandated when you are creating a service. So no longer we are on the mercy of developers maybe skipping certain steps. Lastly, about observability, you've got Kubernetes as a service, but as I told you, you will have heterogeneous environments. You will have services running in VMs while you are migrating to containers. What you don't want is two monitoring system. They're going to get disconnected. You're going to have two views, and you will have a very hard time connecting the dots. So invest in building a single monitoring system. This is just a dashboard of how our 120 node Elastic cluster looks like on a single dashboard. This is an architecture diagram of our monitoring platform. This is using Prometheus, which is our standard geo-distributed monitoring platform. This across the 3 data centers, across everybody, that's where you will find your monitoring stats. It's redundant, it's reliable, it has long-term storage, it has integrations with alerts like email, PagerDuty, Slack. All of that comes standard. Nobody has to invest into creating any of those integrations. You drop in a service, this is available to you at DayZero. You've got automated CI/CD pipelines. There is not a single line of code that anybody will have to write in order to create their pipelines. Their service is dropped, checked in, there's a single merge request. Once it is accepted, a brand new job will be created, which will take you from end to end, from your development all the way to production. In 3 data centers, it gives you the ability to do canary, to do blue-green, and it gives you the ability to roll out in 1 data center at a time. All of that, again, is available to you from get-go. Our testing strategy, there are several, and this is an area that we are investing a lot, is essentially creating environments that are copy-paste, that could be copy-pasted. No longer can we have just one environment. We have a staging environment that should be able to create virtual staging environments in case you're building on a feature that requires slightly different different changes, and you may not be able to be backward compatible with your previous environment. So investing into not just Kubernetes, but copies of Kubernetes is important for that kind of scale. In the end, this is the last slide, is my message to all of you guys is invest in your cloud. Providers like AWS, Azure, GCP are great cloud providers, but the cloud is actually inside of them. The cloud is what you are running of your stack. So please understand the details, do the dirty work, clean up your stack, and then adopt technologies like Kubernetes, which are amazing. That's it, guys.